All right, so our I can for today is I can multiply 4-digit by 1-digit whole numbers. And I have the same problem written out twice, so we can see it in the expanded form, writing out each partial product, and then the standard algorithm, which is like the condensed form, which is the 5th grade standard. All right, looking at A, we have 1,644 times 7. So 7 times 4 is 28. So the expanded form, I'm going to write out each product instead of writing it up here. 7 times 4 is 28. 7 times 4 is 28 again, but for the expanded form, I want to look at it as 7 times 40, or 4 tens, because this 4 is in the tens place. So 7 times 40 is 280. 7 times 6, or 7 times 600, 6 hundreds, because 6 is in the hundredths place, is 4,200. And then 7 times 1, or 7 times 1,000, because the 1 is in the thousands place value, is 7,000. I'm going to add my partial products together. I have 8 ones, 10 tens, or 100, 5 hundreds, and then 11,508 is my product for this problem. Looking at the same exact problem, but instead of writing out each partial product, I'm going to condense it and regroup it all up here and use some mental math. So 4 times 7 is 28, but instead of writing 2 here and adding them all at the end, I'm going to write the 2 up here so I can just regroup as I go along. 7 times 4 is again 28, adding on the 2 is 30, write the 3 up here. 7 times 6 is 42, adding on with the 3 is 45. And then 7 times 1 is 7, adding on with the 4 is 11, 11,508. So I have the same exact answer, but clearly you can see that this method is going to be shorter. It's going to take up less space. It does require, as you write down the products, the partial products, you have to add in your head instead of writing it all out here. But this is the 5th grade standard, so you should be able to do this in 5th grade. But understand conceptually what you're doing and understanding that, no, this is actually not 28 when you multiply 7 times 4 right here. It's actually 280, but you're just regrouping. Looking at B, we're going to do the exact same thing, but with a different problem. So 2,248 times 8. 8 times 8 is 64. Both my 8s are in the ones place, so it's just 64. 8 times 4, 8 times 40 is 320. 8 times 2, or 8 times 200 is 1,600. And then 8 times 2, or 8 times 2,000 is 16,000. Make sure I'm lining up my place value. So I've just written out partial products, part of the product. 4 in the ones, adding them together. 6 plus 2 is 8 in the tens. 3 plus 6 is 9 in the hundreds. 1 plus 6 is 7 in the thousands. And then I just have 1 for the 10,000. So my total is 17,984. For the standard algorithm, 8 times 8 is 64. Instead of writing the 6 here, I write it up here. 4 times 8 is 32. Plus 6 is 38. 8 times 2 is 16, plus 3 is 19. 8 times 2 is 16, plus 1 is 17. Again, same answer, shorter version, regrouping up here, adding on instead of writing out each partial product. Last one, we have C, 2,329 times 9. So expanding out, 9 times 1 is 9, 9 times 2, or 9 times 20 is 180, 9 times 3, or 9 times 300 is 2,700, and then 9 times 2, or 9 times 2,000 is 18,000. I have 4 partial products, 1, 2, 3, 4, I have to add them together, 9 ones, 8 tens, 8 hundreds, regroup to make 20,889. The expanded form, I have 1 times 9, 2 times 9, 18, regroup up here. 9 times 3 is 27, adding out the 1 is 28. And then 9 times 2 is 18, plus 2 is 20,889. So for all of these problems, they're all going to be, the left side, expanded algorithm, the right side the standard. Clearly you can see this is a lot less work. This is great to understand conceptually what you're doing when you're multiplying, but for the 5th grade standard, you should be able to write it out in its standard form. And that's it for I Can Multiply 4-digit by 1-digit whole numbers.